Power supplies. So, we're going to talk about power supplies, their ratings, their voltages, form factors, connections, how we remove and replace a power supply, and testing a power supply, and then we're going to actually do it. So, power supplies, where are they? Well, power supplies are what take the AC voltage from the wall and convert it to DC for use by the computer. If you have unexpected reboots, data corruption, unrecognized USB devices, systems that are overheating, these can all be caused by a bad power supply. You want to make sure you get clean power from the wall going into your computer's power supply, so that way it can transfer it and make it into a DC for a well-running computer. Again, the power supply converts that 120 volts AC into 3.35 and 12 volts DC. And power supply fans remove the heat created during this generation and spit that out the back, trying to cool down the system, because as you're doing this transformation from AC to DC, it creates a lot of heat. Ratings. Our power supplies are rated in watts, okay? And typically, you're going to see 400 watts or greater in today's computers. If you're building a gaming system, usually you're going to see 750 watts or more. Because every time you add more graphics cards, you add more hard drives, you're going to need a bigger power supply to support all that. But if you get like your standard Dell computer, like you have at your feet, those have like a 400 or a 450 watt power supply. The more devices you have in the case, the more power you're going to need. You'll see this backwards UR logo, which you can see right here. That means that it's been safety rated. This allows us to know that this has been safety tested and it's ready to be used in America. Determining our wattage, we add all of our devices together, and if they're rated in amps, we do the amps times volts equals watts thing again, like we talked about with UPSs, with our UP UPSs. And the total wattage, you want to keep it under 70% of your power supply. So that's why we use these really big power supplies, even if we don't need that much. You may only be using maybe 500 watts, but you'll have a 750 watt power supply, right? That's about 66% usage, which would be typical for a gaming machine. And the reason why is these things are not 100% efficient. Generally, they'll start out around 90% efficient, and over time they get weaker and weaker. And so if you start out already being, maximum capacity, and it starts getting weaker over time, it's going to die on you too quickly. So usually around 70% is what the rule of thumb we use. Multi-voltage. So we talked about this a little earlier, that in the US, we use generally around 110 to 120 volts at 60 hertz. Overseas, they use 220 to 240 volts at 50 hertz, or at 50 hertz. It's a typo. In North America, our power, the set is 115 to 120. In Europe and Asia, 230 to 240. And you'll see this little red switch here. That is a little slider switch. And you'll actually put it to the right position. It'll either say 115 or 230. And so if you're overseas, put it to 230. If you're in America, put it 115. Some power supplies do the automatic ranging. Laptops do this, and some desktops do it. What happens if you do it wrong? Well, you're here in America. Let's say we plug into the American wall outlet, which is 115. But your thing is set to 230. What do you think is going to happen? It's not going to turn on. It's not enough power. It's expecting 230. You're only giving it 115. Nothing's going to happen. It won't turn on. Okay? Let's reverse that. We set it to 110, or 115, excuse me. And I take it over to London, England, and I plug it into a 230 outlet. What's going to happen? Well, boom, right? It's going to go boom because it's got too much power for too little capacity. So in America, not as big of a deal. You're over in Europe, big deal, right? So you got to be knowledgeable about that before you plug in the machine. So our power supply form factors. There are two major types of form factors. The old style is what's called a 20-pin, which is the old ATX family. And the new one is called a 24-pin, which is for ATX and BTX motherboards, with the new 2.2 power supply standard. What you're going to find in the market nowadays is a 24-pin, okay? What most of the new ones have done to allow for backwards compatibility is they do what's called a 20 plus 4 connector. When we open ours up, you'll see that. And what it is it's really the 24 pins, but they've broken off the last 4 pins so that when you put them on a newer board, you put them all together as one big chunk. But if you're using an older board, you can just use the 20 pins. So they allow for backwards compatibility. ATX 12 volt is a 4-wire square for additional motherboard power. You can see that in the bottom left corner of the screen here. It's a little 4-pin adapter, 2 on top, 2 on bottom. The ESP 12 volt is an 8-wire connector which you'll see right next to it. Additional power supply right there. The aux connector, that's the aux connector. This is 6-pin aux connector. The 8-pin basically looks like two of these ATX ones slapped together. That gives eight wires. That's usually used for backwards compatibility as well. It's being split. Up top, we have another bundle of wires, which is what it looks like when you open up your computer. Each of these is for different things. We'll talk about them later. We've got some Molex connectors. We've got some CPU power. We've got some hard drive power, or to me, floppy drive power. And then the 20-pin connector at the top there. So, over here, you can see Molex, which is used for our hard disks. It's used for older CD-ROM and DVD drives. It's used for fans. And the Molex is right here, these 4-pin connectors. They kind of look like a roundish rectangle with 4 pins on it. The Burge connector is there it is this tiny one here. Let me bring this back. This here is a Burge connector. It's got a 4-wire connector. It's a very small rectangle. That's used for floppy drives. You're not going to run across those very often anymore. The SATA connectors, they are long and L-shaped. So it's got a little L here, and that's used for SATA hard drives, as well as optical drives like DVDs and CDs. PCIe X16 cards, the video cards need additional power because the motherboard slot doesn't give them enough power. So they have these 6-pin or 8-pin extra video cards slots that can plug in there. That's the same thing as what this is. If you don't have any of these connectors, you can actually take 2 Molexes and use a wide actor like this and create one. So you can actually transmit things. Just like wide actors can have more connectors of a certain type, then convert one to another. And again, before I told you that we had this 3.3, 5 volts, and 12 volts of DC power being provided to devices. That's what all these different cables are providing based on the device's needs. You want to remember those 3 voltages, 3.3, 5, and 12. Those are important. You'll see them on test questions. Removing the power supply. So removing them is not too hard. You either need a screwdriver or a nut driver, depending on the type of screw that's holding them in. First thing you want to do is power off the computer. Makes sense, right? We want to turn the switch to off if your power supply has one. Our power supplies do not have a switch that physically turns off, I don't believe. If they do, turn it to the big O, which is O for off. You'll disconnect the power cable, by actually unplugging it from the power supply. You'll open the case so you can fully see the power supply. You'll disconnect all the power cables from all the devices, the CD-ROMs, the hard drives, the motherboards, the fans, all that stuff. And then you'll remove the 4 screws, and then it will actually just lift the power supply. It just kind of slides out into your hand, okay? At that point, you'll take the new one, and you'll put it back in. Make sure that the new power supply matches. Make sure it's the right kind of connectors. Slide it back into the case, put the screws in, connect everything back up. Check the voltage settings. Make sure it's 110 or 230 like appropriate. Connect the power cord, turn the computer back on. Verify it's working properly, and then at that point you can go ahead and close the case. The reason why we don't close the case ahead of time is because if it's not working, you have to go back in there, right? So it's okay to run the case with the side open. That's not going to hurt anything. Just don't put your hands in there while it's on, right? How do you test the power supply? Well, use a power supply tester, okay? Or you can use a multimeter, either way. We're going to use a power supply tester because they're a lot easier to use, and they're not that expensive, and I highly recommend for a PC technician to have this bag. It's a lot easier than multimeter. Basically, what you're going to end up doing is you're going to take this and you're going to connect the different cables from the power supply to it, and it will turn green or red to show you it's good or bad. And I'll bring one out, and we'll actually do that on ours and make sure that you can see it during the lab. Avoiding hazards. So, we talked about this before, but never disassemble a power supply. They're throwaway components. If you think it's broken, use a tester. If the tester comes back that's broken, throw it away. Never push metal tools through the openings of the power supply, because again, if you touch those capacitors, they're going to discharge into you, and that's going to hurt. If you're working on a Dell had proprietary power supplies, so a lot of their machines don't use standard ones. So before you go to the store to pick one up, you might want to open it up and see what the power supply is and take it with you, okay? Because they actually had ones that only worked in Dell, and they weren't cross-manufacturer available. Also, you want to use properly wired and grounded outlets for your computers and accessories. This little device here I'm showing you is about $2 at Home Depot. You plug it into an outlet, and if the two lights go yellow and not red, that means the outlet is properly wired and grounded. And if it's not, you'd call an electrician and they'd fix that outlet for you, right? But that's a good thing to test to make sure the outlet is good, because a lot of times we just assume the power outlet is good without knowing, right? And so you might be troubleshooting a computer, and it's not the computer's fault, it's the power outlet's fault. So here's a simple question for you. The modern ATX power supplies employ motherboard power connectors with how many pins? C, 24 pins, right? And for backwards compatibility, they often do a 20+4, where they split that connector in half.